Hello again. This is Math 1120 coming to you from the College YouTube page. And the title of this lecture is Models, Units, and Vectors. As always, please be an active learner as you watch this video. Much of the natural world is arranged in patterns that can be described by means of fairly simple mathematics. Like all sciences that seek to explain the natural world, physics relies on a certain amount of mathematics to express its concepts in precise ways. In studying physics, then, you will need some basic math skills in order to understand the lectures, read the textbook, or succeed on your homework and on exams. The beauty of physics cannot be fully appreciated if you do not have an adequate mastery of basic mathematical skills. Now, instead of what's said here, Linda and I are adopting a just-in-time approach. We're not covering all the math in the world tonight, just what we need. So we're reviewing or revealing math in context, just in time. In physics, we frequently encounter very large and very small numbers. This was the whole point of the powers of 10 video. And it's important to use the proper number of significant digits when expressing a physical quantity. Both of these issues are addressed by using scientific notation. And so we take something like 6.3 but times 10 to the fourth power. Now that means I move this decimal point 4 places to the right because this is plus 4. So this number really represents 63,000. If the power of 10 is negative, it moves the other way. For example, 6.56 times 10 to the minus 3 is, I move the decimal point 3 places to the left, and I get 0.00656. And so what we do is, we move the decimal point, and this is called scientific notation. Now, in ultrasound itself, you will have high frequencies in megahertz and short times in microseconds. So we will be using scientific notation. When we do calculations in scientific notation, we have to use properties of exponents. So for example, suppose we're taking 8.43 times 10 to the 8th times 2.21 times 10 to the minus 5. Well, we can multiply the digital numbers and getting this, but then we can use property of exponents on the powers of 10. So this is 10 to the 8th times 10 to the minus 5. We add those exponents, and the answer is 10 to the minus 3. So this is going to be 18.6 times 10 to the minus 10 to the 3, or if I write this in pure scientific notation, this is 1.86 times 10 to the 4th. Similarly, if I were dividing, I could divide the digital numbers, getting 2.0, but then I look at the ratio of the exponents. This is 10 to the minus 3 over 10 to the minus 6. I subtract exponents. A minus times a minus is a plus, and I get this is 10 cubed. Now, your calculator will do this and Excel will do this, but it's good if you understand how it's doing. And so that's an important consideration in doing these calculations. You also will sometimes have to use geometry, and here's some geometry formulas that are referenced in the mathematical review section. And in particular on the LSA that you're working on right now, you do have to use the volume of a cylinder, a right circular cylinder. And so the volume here is pi r squared, where r is the radius of the base, times the height. We also are going to use trigonometry. We are going to be using right triangle trigonometry. I'm going to do this by components only. In a right triangle, one angle is 90 degrees. That's what it makes it a right angle, and that's why we use this little symbol here to say that's the 90-degree angle. The other two angles are acute, and they add up to 90 because the sum of the angles interior to a triangle are called sum to 180. The side opposite the right angle is called the hypotenuse, and it's side C in this figure. In a right triangle, if we take c squared, the hypotenuse squared is equal to the sum of the legs squared. So c squared equals a squared plus b squared. That's the Pythagorean theorem, and yes, you will need that. You also will need to be thinking about trigonometric functions, and we're only going to be worrying about the sine of theta, the cosine of theta, and the tangent of theta. But that says if this is the angle theta, then the sine is the opposite side over the hypotenuse, or A over C. The cosine of theta is the adjacent side over the hypotenuse, that is B over C, and the tangent of theta is the opposite side over the adjacent, which is A over B. Now these functions are in your calculator, are in Excel, and they're on the calculator on your screen. And Linda will show you how to use those, but these are buttons that you have on your calculators, and we will be using these in our calculations. These will be in the grace notes, but you will need to be able to use these relationships. So let's do an example. A right triangle has an angle of 30, and one side is of length 8, and this is the side of length 8 here. Okay, so I can use right triangle trigonometry to ask, what is angle phi? Well, angle phi has to be 60 degrees because these two have to add to 90. And what are the lengths of x and y? Well, we know that the tangent of 30, the opposite over the adjacent, is 8 over x. So I punch this into my calculator and figure out what the tangent of 30 is, and then I can solve this equation for x, and I get that x is equal to 13.9. And then to find out what y is, I can use the Pythagorean theorem. Y squared is equal to the sum of those squares, and I take the square root, so y is 16 centimeters. And so those are ways that you could solve a problem like this. And we're going to use these to solve some vector problems in a bit. There's another great problem that happens, and we have inverse trig functions, which up here, you're going to hit the second here, get the inverse trig functions, and Linda will show you how to do that in calculators and Excel when we go through it. But this allows you, if you know these sides, to find out an angle. So let's suppose, here's another example, a right triangle has two sides and the lengths are as shown. We know that this is 3, this is 5, and that is x. So what is the length of x and what is the angle theta? Well, the length of x can be found by the Pythagorean theorem because we know that 3 squared plus x squared is equal to 5 squared. So x is equal to 4. We can solve using the Pythagorean theorem. And we know the cosine of theta is 3 over 5, so that means that theta is the inverse cosine of 0.6, and that is going to be 53 degrees. Animals use physics too, and in fact this bat uses the laws of physics, and the reason this is interesting, I think, is that to locate and capture these flying mammals exert an extremely rapid series of bursts of high frequency sound, just like ultrasound. And without a stopwatch or a calculator, they can figure out the direction of the reflected sine waves and the time it takes for them to reach them, and that means they can go and catch their prey. Units are important in physics. You always include units, and we're interested in length, which in the SI system of measurements is meters, time is in seconds, and mass is based on kilograms. In the British or English system, the units are feet for length, seconds, and slugs are the unit of mass. We'll say a lot more about this, but this is where we really start, is with units, and units must always be included for your answer. They're very important. We're going to have these basic units, and we're also going to have some derived units. Very important stuff in physics, in science, and in ultrasound. And there's also a whole bunch of names and abbreviations for these various powers of 10. We talked about some of those. My hard disk has terabits. The speed of my processor is in gigabits. You're going to use megabits, megahertz for your frequencies. We talked about kilograms, centigrams, milligrams. So you want to be familiar with this table because sometimes they'll use the prefixes, sometimes they'll just use the powers of 10, and you have to be able to change from one unit to the other. And the powers of 10 video talked about going all the way up to 10 to a very high power and down to 10 to a very low power. And even though you don't go quite this wide, you talk about a wide range in ultrasound as well. And there have been some very expensive mistakes made with units. The earlier, now Percy's doing just fine on Mars right now, the Perseverance probe, but there were earlier probes in the late 90s that in fact crashed because of mistakes in units that engineers who should have known better made. So units are very important, and here this cost billions of dollars. Now, often what we'll do is convert between units. So here is, we say, although there's no maximum speed on the Autobahn, signs in many areas recommend a top speed of 130 kilometers per hour. We want to express this in meters per second and in miles per hour. So we have to, and I did give you a copy of the appendix in the book that I pointed at, but we know that 1 kilometer or kilometer is 1,000 meters because that's one of the prefixes that we know. And a mile is 1.609 kilometers. An hour is 60 minutes or 3,600 seconds. So we can change 130 kilometers per hour. We take 130 kilometers per hour times 1,000 meters per kilometers. The kilometers cancel. And now we have meters per hour. So we take this 1 hour times 3,600 seconds. Again, notice these conversion factors really are 1, and so the hours cancel with the hours, the kilometers cancel, and so I have meters per second. I do the arithmetic, multiply across the top, across the bottom, do the calculation, and I get meters per second. Similarly, I can use the conversion between miles and kilometers to make the kilometers cancel, and if you're going 130 kilometers per hour, you're going 80.8 miles per hour. This is known as dimensional analysis, and that's one of the important skills that I'm sure we will be testing you on in LSAs as well as HSAs. Let's do another problem. Let's convert 13.7 times 10 to the 9th years. And by the way, that is how old the universe is. So I can change that into seconds. This is seconds per year. And I get how many seconds are there in a year. 10 to the 17th, of course, is a very big number. I can also change 4.7, which is how long ago in seconds our species, I guess that's Homo sapiens, emerged, and we can change that to years. I use this conversion factor and get this. Make sure that you know how to do these problems, these kinds of problems. And sometimes we do estimates. So let's use some estimation to figure out if it's possible for a spy scenario, for a spy to escape across the border with $1 billion worth of gold in his suitcase. Is this possible, and how heavy would it be? Well, gold sells for $1,500 an ounce. At least that's what it was when this book was printed. On a particular day, the price might be something different, but what we're saying is that's just the price that we will use. Now, an ounce is 30 grams, so that allows us to change the pounds, the $1 billion into ounces, and so we can do a calculation and figure out that the weight of the suitcase is going to be 22 tons, which means this is not a reasonable kind of thing. Make sure that you understand how to follow this kind of calculation. Pausing the video might be good, and you're using the density is mass over volume. Now, some physical quantities are described just by a single number and a unit. They're called scalars. But other things have magnitude and direction, and these are called vectors. And we're going to use vectors in much of what we do because vector quantities play an essential role in all of physics. And so we're going to talk about what vectors are and how to combine them. Vectors have a little arrow over them. And if we talk about the magnitude of vector, we take absolute value symbols to talk about the magnitude. The magnitude is always positive, and two vectors are the same if they have the same magnitude and point in the same direction. Okay, so we're going to be doing much things with vectors, and we're going to be using our trigonometry to do it. So here is the problem. In this problem, we'll use vector addition. And so suppose on a cross-country trip you go 1 kilometer north and 2 kilometers east. So you go 1 kilometer north and 2 kilometers east. So how far did you get, and what angle are you from your original direction? Well, this is one side, that's the other side. So I can figure out the third side, the resultant displacement, by the Pythagorean theorem, and it's 2.24 kilograms. But then I can also use the fact that the tangent of theta is 2 over 1, so I can use my inverse tangent to find that theta is 63.4 degrees. So the magnitude is the length of this, which we found was 2.24, and the direction is 63.4 east of north. Now we can do other kinds of problems, and often what we're going to do is break things into components. So we have this guy named Raoul, and Raoul goes off at 35 degrees up here, and this is the vector A. Well, we break vector A into perpendicular components. So we have AX and AY. And we know that AX is A times cosine theta, and AY is A times sine theta. And we have another person named Maria going down here. Now notice that Maria is going 55 degrees in this quadrant, so this is negative, and this is negative. So you see I can use my trigonometry to calculate that Raoul, how far did he go in the x direction, and how far did he go in the y direction, and similarly for Maria. Notice that Maria, though, these are vector quantities, so Maria is negative in both directions. Now here's a problem where we were going 74.4 meters, 32 degrees east of north. Then we go 57.3 south of west, and then we go 17.8 straight south. Well, this is vector A. So vector A we split into AX and AY. And so you see I can calculate these based on knowing this angle of 32 degrees. So I can calculate the sine and the cosine of that, and I can find out, you see this was 32, so this other part is 58. I can get these, and these are both positive and positive. B is going south of west, so B is going down here, so both of these are going to be negative, and C is just going straight down. But you see what I can do is I can add the x components and the y components, and I get the components of the resultant. I can use the Pythagorean theorem to figure out how long the resultant is, and I can use theta, where I look at the ratio of the opposite over the adjacent, to figure out what is this angle. We're going to be doing problems like this, and so we'll do some of these together in the VCM that's upcoming. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. May God bless you all. See you in the VCM tomorrow night.